H100 is the first PCI Express Gen 5 GPU and the first HBM3 GPU. A single H100 sustains 40 terabits per second of I/O bandwidth. To put it in perspective, 20 H100s can sustain the equivalent of the entire world's internet traffic. The Hopper architecture is a giant leap over Ampere. Let me highlight 5 groundbreaking inventions. First, the H100 has incredible performance. A new tensor processing format, FP8. H100 has 4 petaflops of FP8, 2 petaflops of FP16, 1 petaflops of TF32, 60 teraflops of FP64 and FP32. Designed for air and liquid cooling, H100 is also the first GPU to scale in performance to 700 watts over the past 6 years through Pascal, Volta, Ampere, and now Hopper. We developed technologies to train with FP32, then FP16, and now FP8. For AI processing, Hopper H100's 4 petaflops of FP8 is an amazing 6 times the performance of Ampere A100's FP16, our largest generational leap ever. The transformer is unquestionably the most important deep learning model invented. Hopper introduces a transformer engine. The Hopper transformer engine combines a new tensor core and software that uses FP8 and FP16 numerical formats and dynamically processes layers of a transformer network. Transformer model training can be reduced from weeks to days. For cloud computing, multi-tenant infrastructure translates directly to revenues and cost of service. A service can partition H100 up to 7 instances. Ampere can also do this. However, Hopper added complete per-instance isolation and per-instance I/O virtualization to support multi-tenancy in the cloud. H100 can host 7 cloud tenants, while A100 can only host 1. Each one is equivalent in performance to 2 full T4 GPUs, our most popular cloud inference GPU. Each Hopper multi-instance supports confidential computing with trusted execution environment. Sensitive data is often encrypted at rest and in transit over the network, but unprotected during use. Data can be an AI model that results from millions of dollars of investment, trained on years of domain knowledge or company proprietary data, and is valuable or secret. Hopper confidential computing, a combination of processor architecture and software, addresses this gap by protecting both data and application during use. Confidential computing today is only CPU-based. Hopper introduces the first GPU confidential computing. Hopper confidential computing protects the confidentiality and integrity of AI models and algorithms of the owners. Software developers and services can now distribute and deploy their proprietary and valuable AI models on shared or remote infrastructure, protecting their intellectual property and scaling their business models. And there's more. Hopper introduces a new set of instructions called DPX, designed to accelerate dynamic programming algorithms. Many real-world algorithms grow with combinatorial or exponential complexity. Examples include the famous traveling salesperson optimization problems, Floyd-Warshall for shortest route optimization used for mapping, Smith-Waterman, pattern matching for gene sequencing and protein folding, and many graph optimization algorithms. Dynamic programming breaks complex problems down to simpler subproblems that are solved recursively, reducing complexity and time to polynomial scale. Hopper DPX instructions will speed up these algorithms up to 40 times. H100 is the newest engine of AI infrastructures. H100s are packaged with HBM3 memories, using TSMC's CoWoS 2.5D packaging, and integrated with voltage regulation into a super chip module called SXM. Let me now show you how we build up a state-of-the-art AI computing infrastructure. 8 H100 SXM modules are connected by 4 NVLink switch chips on the HGX system board. The 4 super high-speed NV switch chips have 3.6 teraflops of sharp in-network computing, first invented in Mellanox quantum InfiniBand switches. For all-to-all reductions, used extensively in deep learning and scientific computing, Sharp effectively boosts bandwidth by 3 times. The CPU subsystem consists of dual Gen 5 CPUs and 2 networking modules, each with 4 400 gigabits per second CX7 InfiniBand or 400 gigabits per second Ethernet networking chips. CX7 has 8 billion transistors and is the world's most advanced networking chip. A total of 64 billion transistors deliver 3.2 terabits per second of networking. Introducing the DGX H100, our new AI computing system. DGX has been spectacularly successful and is the AI infrastructure for 8 of the top 10 and 44 of the Fortune 100. Connected by NVLink, DGX makes the 8 H100s into one giant GPU. 640 billion transistors, 32 petaflops of AI performance, 640 gigabytes of HBM3, and 24 terabytes per second of memory bandwidth. DGX H100 is a spectacular leap. And there's more. We have a brand new way to scale up DGX. We can connect up to 32 DGXs with NVLink. Today, we're announcing the Nvidia NVLink switch system. For AI factories, DGX is the smallest unit of computing. With NVLink switch systems, we can scale up into one giant 32-node, 256 GPU DGX pod with a whopping 20.5 terabytes of HBM3 memory and 768 terabytes per second of memory bandwidth. 768 terabytes per second. In comparison, the entire internet is 100 terabytes per second. Each DGX connects to the NVLink switch with a quad-port optical transceiver. Each port has 8 channels of 100 gig PAM4 signaling, carrying 100 gigabytes per second. 32 NVLink transceivers connect to a 1-rack unit NVLink switch system. The H100 DGX pod is essentially one mind-blowing GPU. 1 exaflops of AI computing, 20 terabytes of HBM3, 192 teraflops of sharp in-network computing. The bisection bandwidth moving data between the GPUs is an amazing 70 terabytes per second. Multiple H100 DGX pods connect to our new Quantum 2 400 gigabits per second InfiniBand switch with sharp in-network computing, performance isolation, and congestion control to scale to DGX superpods with thousands of H100 GPUs. Quantum 2 switch is a 57 billion transistor chip with the ability to connect 64 ports of 400 gigabits per second each. DGX superpods are modern AI factories. We are building EOS, the first Hopper AI factory at Nvidia, and she's going to be a beauty. 18 DGX pods, 576 DGXs, 4,608 H100 GPUs. At traditional scientific computing, EOS is 275 petaflops, or 1.4 times faster than the fastest science computer in the US, the A100 powered Summit. At AI, EOS is 18.4 exaflops, or 4 times the AI processing of the world's largest supercomputer, the Fugaku in Japan. We expect EOS to be the fastest AI computer in the world. EOS will be the blueprint for the most advanced AI infrastructure for our OEMs and cloud partners. Partners can take H100 DGX SuperPod as a whole, or the technology components, at any of the 4 layers of our platform. We are standing up EOS now and will be online in a few months. Let's take a look at Hopper's performance. The performance boost over Ampere is incredible. Training transformer models. The compound benefits of Hopper's raw horsepower, Hopper transformer engine with FP8 tensor core, NVLink with sharp in-network computing, NVLink switch scale up to 256 GPUs, and the Quantum 2 InfiniBand, and all of our software results in a 9x speedup. Weeks turn to days. For inferencing large language models, H100 throughput is up to 30 times higher than A100. H100 is the most significant leap we've ever delivered. Nvidia H100, the new engine of the world's AI infrastructure.